Okay, hello everyone. Welcome to the demo of our project, the Medical Assistant AI. And this is locally deployed dual agent system designed to bridge the gap between complex medical imagery and patient understanding. We started this project by identifying a critical communication gap between in healthcare. On one hand, medical imaging reports like X-ray or CT scans are filled with dense technical jargon that the average patient simply cannot understand. On the other hand, doctors are incredibly busy, so they often lack the time to sit down and translate these technical findings into plain language for every single patient. To solve this, we built a dual agent system. First, we have the radiologist agent, powered by the MedGemma vision language model. It acts as a technical expert, analyzing the raw image. And second, we have the doctor agent, powered by the Llama 3. It acts as the communicator, translating those technical findings into empathetic, actionable advice for the patient. And the core of our orchestration is built on LangGraph. Unlike simple linear chain, LangGraph allows us to build a stateful workflow where agents can cycle and make decisions. And today I will show you how we build this and, more importantly, how we made it private and secure. Our architecture uses a stateful graph to manage the flow of information. As the graph showing here, it will conditionally move from the user input to the radiologist node or directly to the doctor node based on the context. Our router logic determines that if the user uploads an image, the router directs the state to the radiologist node, and it is responsible for generating the medical report based on the image, then together pass to the doctor node. If the context is a text-only follow-up, is a text-only questions, it routes directly to the doctor node, and it is responsible for generate plain explanation to the patients. And now I want to emphasize the most critical aspect of this project. It's privacy and compliance. Medical data is highly sensitive. Uploading patient X-rays to the public cloud API poses a massive risk of data leakage and violations. We solve this pain point by running everything locally using Llama. So both MedGemma and Llama 3 run entirely on the local machine. This aligns with the concept of edge AI. By moving computation to the edge, right where the data is created, we ensure that no patient data ever leaves the local network. This makes our system inherently compliant with data privacy regulation by design. It's not just an AI tool, it's a secure, self-contained medical infrastructure. Finally, for the agent to behave correctly, we utilize system prompting. We explicitly instructed the video M to act as an analytic radiologist focusing on visual evidence, while the Llama 3 node is prompted to be an attending physician who prioritizes clarity and empathy. Now let's see in action. So here is our medical assistant front end, and I will try uploading a chest X-ray image, and my prompt will be I have chest pain is this normal? Should I be worried? Yeah, and we will give it some time to analyze and generate response. Okay, now we can see the streaming response. Here is the analysis of the patient's questions and the medical image. It says it looks normal, and then it will answer the patient's questions and then give some next steps action to the patient. Yeah, and you can see this successfully bridged the gap between the raw visual data and the patient's need for advice. Yeah, we can also test the router's flexibility. Like, let's try this examples. What are common symptoms of seasonal allergies? Yeah, this is a text-only questions, and the system recognizes this is a text-based query, and it will skip the heavy vision model entirely and go straight to the doctor node, the doctor agent. So this saves computational resources and generate a response like this. Yeah, and this is another benefit of our Edge AI architecture. Okay, so to summarize, our project demonstrates that we don't need to sacrifice privacy for intelligence. By combining the LangGraph for workflow management and Llama for local execution, we create a system that is automated, user-friendly, and secure. So looking ahead, our next step is that we want to integrate RAG. This could allow the doctor agent to cite specific medical guidelines or journals when giving advice, which can increase reliability for the response. And we can also do domain fine-tuning. So we can fine-tuning on local hospital data to adapt to some specific terminologies and rare pathologies. So this is the end of our demonstration. Thank you for your time.